Let's talk about the absolute value function of a number. The absolute value of a number is actually the distance between that number and 0. Take for instance, if I have a, which is a number, the absolute value of a is actually a because the distance between a and 0 is actually given as a. So the absolute value function, like I said, is the distance between 0 and a particular number. Now, if I have, let's say, absolute value of minus a, the absolute value of minus a is still a because the distance between 0 to minus a is still a. Because in distance, we do not consider distance to be negative. Also in physics, distance is never considered negative. Now let's talk about the properties of absolute value functions. The absolute value of a is greater than or equal to 0, meaning that the absolute value of a number must be positive. Another property is that the absolute value of negative a must be equal to the absolute value of positive a, and it must be greater than or equal to 0. Now what that means is that if I have 0 here and I have positive a and a negative a, the distance of positive a to 0 is still the same thing as a, and the distance of negative a to 0 is still the same thing as a. Now for the third property, if I have two numbers a and b, then the absolute value of a minus b actually tells the distance between them. That means if I have this to be the position of a and this to be the position of b, then the absolute value tells the distance between a and b. Now given an unknown, let's say x, and we have that the absolute value of x is equal to 2. This function is actually a linear function that tells you the values of x that has a distance of 2 from 0. So now we can actually have two values here. Let's say we have our point 0 here, then we have a distance of 2 here, and likewise we should have a distance of 2 on the left hand side. So the number that has a distance of 2 away from 0 is 2, and another number that has a distance of 2 away from 0 is negative 2. So here we can actually say that the absolute value of x equals to 2 means that x takes two values, either a negative 2 or a positive 2, is equal to negative 2 or 2. So let's consider the absolute value of x minus 3 equal to 4. So here we see that it's either we have that x minus 3 is equal to a negative 4, or x minus 3 is equal to a positive 4, considering the left and right hand side of the values of x. So now for this we have that x will be equal to a negative 4 plus 3, and that gives us a negative 1, or we have here that x is equal to a positive 4 plus a 3, and x is equal to 7. So we can also verify that by substitution. If we substitute negative here, we can actually see that the absolute value of negative 1, negative 3 is actually the absolute value of negative 4. The absolute value of negative 4 is 4. And similarly, the absolute value of 7, which is our x minus 3, is still the same thing as the absolute value of 4, which is equal to 4. Let's consider the absolute value of 3x minus 1 less than 2. Now, if you have a number, say 1 less than 2, then the negative side of 2, negative 2 will be less than 1, and 1 will be less than 2. So we are going to use this scenario now to rewrite our function as an interval. So we can actually write this function 3x minus 1 as negative 2 less than 3x minus 1 and less than 2. So we're going to solve the first side of our interval and the second side of our interval. So for the first side, we can have that negative 2 is less than 3x minus 1. So that means here we have that about negative 1, because if we do this plus that, is negative 1 will be less than 3x. And we have negative 1 over 3 is actually less than x. Now coming to this other side, we have that 3x minus 1 is less than 2, implying that 3x is actually less than 2 plus 1, and 2 plus 1 gives us a 3. So we see here over 3 and over 3. So we have that x is actually less than 1. So you can see two conditions here. The first one is that negative 1 over 3 is less than x and x is actually less than 1. So in the graph of this, we can actually have this, that this is a boundary between 1 and negative 1 over 3. And we should have our point 0 between them. So if we are to test this inequality, it will be an open ball from negative 1 over 3 down to another 4.